All right, so picking up from last time, I think we need to start with letter D. Letter D is another application of the chain rule. The outside function is cosine. So the derivative of this is, well, what's the derivative of cosine minus the sine? So I go minus the sine, x cubed plus 2x. Chain rule says times the derivative of the inside, which is 3x squared plus 2. Okay, and we can just leave it like that. So let's look at E. E, again, multiple application of the chain rule. The outside function is natural log. What's the derivative of the natural log? 1 over the inside. So I go 1 over tangent of x squared. Then I have to differentiate tangent. The derivative of tangent is secant squared. So I go secant squared x squared. And then again, by the chain rule, I have to take the derivative of the inside here, which in fact is 2x. And when I clean things up, then I get 2x secant squared x squared over tangent of x squared. And we can just leave it like that. All right, now let's look at some applications of integrals. Remember, there's two kinds of integrals. A definite integral, which corresponds to area, signed area, or area between curves, and an indefinite integral, which simply asks the question, find all antiderivatives of particular functions. The first one is an indefinite integral, so it just find all antiderivatives. You have to undo the power rule. And the integral of the sum is the sum of the integrals, so you can do each one separately and then just add them up. What do you get? Well, you have to raise the power by 1 and divide by that, so you get x cubed divided by 3. The 3's cancel, so you just get x cubed. When you integrate x, you get x squared over 2. When you integrate minus 3 times x to the 3 halves, that 3 halves is meant to be a power there. What do? You have to raise the power by 1. That gives you x to the 5 halves. Then you have to divide by that power. Well, that's the same as multiplying by the reciprocal. So you multiply by 2/5. That leaves you with this term plus c. When you clean things up, you get this right here, x cubed plus x squared divided by 2 minus 6/5. 3 times 2 is 6 minus 6/5 x to the 5 halves plus c. Alrighty, at this point, you know only one integration technique, okay, and that's called U substitution. Now, I look at U substitution as undoing the chain rule, which means there has to be inside here, there has to be function composition. And here it is, garbage to the 8th. So what's garbage? What's the inside? 3x squared plus 5. There's your hint. U is 3x squared plus 5. U is always the inside function where your function composition is happening. So if U is 3x squared plus 5, du is the derivative of that, which is 6x dx. And I want to encourage you to keep the dx. It makes a difference. Don't drop it. Because in particular, now I'm going to take dx and solve for it. So dx is 1 over 6x du. And now what I'm going to do is I'm going to take this whole thing and substitute in. All right, so to begin with, I get a what? U to the 8th. Then I get an x. And then dx, which is 1 over 6x du. Here it is. That's dx. What do I notice? That my x's cancel. The 1/6 comes all the way out, and I just get 1/6 the integral of u to the 8th du. Now, I can proceed because all my x's have gone away. I'm only talking about u. So I just need to integrate u to the 8th, which is u to the 9th divided by 9. Remember, I have a 1/6 out here. U to the 9th divided by 54, add c. I'm not done yet because I need to plug back in for u. And I get 3x squared plus 5 to the 9th divided by 54, add c. And that's a little review of u substitution. The next example is u substitution, and it is a definite integral, so from 0 to pi over 4. Notice that the inside function here is, the outside function is sine, the inside function is 2x. That's how I get let u be equal to 2x. Okay, then what's du? Du is 2dx. Solve for dx. Dx is 1/2 du. Plug everything in. What do I get? Well, first off, since it's a definite integral, I have limits here, but those limits are good for x. They are not good for u, and that's why I put a little line right there to remind me it's still a definite integral, but those limits were for x and not u. Then I go what? Sine of u, because u is 2x. And then in place of dx, I write 1/2 du. 1/2 du. All right, and now I look at that, I get the integral of 1/2 sine u du. The 1/2 goes all the way out. I just need to integrate sine of u, which is minus cosine of u, and that's how I get this next piece, minus 1/2 cosine u. Again, it's a definite integral, so among certain limits, but these original limits were only good for x, not u. Finally, instead of u, I replace it with 2x. Once I'm talking x again, I can put the limits back in. So from 0 to pi over 4. Now, how do you evaluate a definite integral? It's this function, plug in pi over 4, subtract this function, plug in 0, and that's what I've written right there. Now you'll notice that when I plug in pi over 4, it's going to be 2 times pi over 4, which is pi over 2. When I plug in 0 at the bottom, it's just going to be 0. And I notice cosine of pi over 4, that should be a value you know. That's just 0, because cosine of pi halves is 0. So minus 1/2 times 0, and then minus a minus gives me a plus. Cosine of 0 is 1, and that's how I get an answer of plus 1/2. So there's kind of a review of u substitution and how it works with a definite integral. Now I'm going to look at the chain rule for the derivative in a little different way. All right, so suppose f is a function of u and u is a function of t, then really f is a function of t. And if f is a function of t, it makes sense to ask what is df dt. And I can ask that question at any time t. In particular here, I'm going to ask it when t is 1. All right, so one way to think about the chain rule is outside in. The other way to think about the chain rule is this. df dt by the chain rule is the derivative of the outside, that is df du, times the derivative of the inside, which is du dt. So the chain rule says df dt is df du times du dt. Now here I'm taking a derivative at a particular value of t. So df dt at t equal 1 is df du at some u value, and that u value is when t is 1, times du dt at t is 1. So how do I figure out this value right here? Well, u is 4t cubed minus t. So u of 1 is 4 times 1 cubed minus 1, right? Plugging in 1 for t. And that gives me 4 minus 1, or 3. That's how I get u equal to 3. That's what I need to plug in, right? All right, so df dt at t equals 1 is this. When I plug in 3, well, plugging in 3 gives me what? 9 minus 1 on the inside, that's 8. 8 squared, 3 times 3 is my 9. And then I plug in t equals 1 over here. What do I get? 12 minus 1 is 11. Ugly number. I claim if you crank things out, you might get 6,336. And that, my friends, is as far as we got in the second lecture.